Okay, we are covering chapter 22. We are covering chapter 2 on chemistry, and the role of enzymes is that they lower the activation energy. So the activation energy of a reaction is the amount of energy it takes for that reaction to take place, the amount of energy required to start a reaction. So enzymes will lower that amount of energy, and by lowering the amount of energy required, it makes the reaction speed up. So it affects the reaction rate. So enzymes lower activation energy, and because of that, they are characterized or categorized as catalyst, because a catalyst speeds up a reaction, and they're proteins. Enzymes are protein catalyst. So without the enzyme, it may take a lot more energy for these reactants to react and form products. But with the enzyme, it takes a lot less energy, meaning it's going to take a lot less time. All right, exergonic reactions release energy. These are our breakdown reactions or hydrolysis reactions. And endergonic reactions require energy. They absorb energy. And so those are going to be our synthesis reactions, the dehydration synthesis reactions. All right, what is an enzyme? A protein catalyst. And why are enzymes needed in our cells? To speed up the chemical reactions that occur in our cells, to make them go at a rate that we need them to go at so that we can still live, because if they take a year and they're supposed to take a few minutes, then we're not going to live that year, We're not going to live the time it takes. So that's why we need enzymes to lower activation energy and speed up reactions in our body so they don't take years, so they take minutes rather than years. And some of them take seconds. So what are nutrients? Nutrients are substances from food necessary for normal physiological functions. They're going to include carbohydrates, proteins, and fats, which are our main food groups, and then vitamins, minerals, and water. And vitamins tend to be organic. Minerals are metals, and then water. Minerals would be like sodium and magnesium, zinc, Metabolites are substances involved in or else a byproduct of metabolism. Now, this definitely you need to know. You need to know that if an organic compound, if a chemical is an organic compound, it must have carbon and hydrogen together. And I don't care if my pointer doesn't work. I'm going to circle this because you have to know this. Okay, or my pen, not my pointer. Well, at least it didn't strike through anything. But I don't understand. So anyway, they must have carbon and hydrogen. Must have carbon and hydrogen to be classified as organic. Okay? Distinguish between inorganic and organic. Well, organic compounds have the element carbon along with the element hydrogen. All right, properties of water. And these are due to the hydrogen bonding that water is able to do due to water's being a polar covalent molecule and also being able to form hydrogen bonds. So water is the most important substance in the body. There are three general properties. Water is an essential reactant in the chemical reactions of living systems. You saw that when a large molecule is broken down, water is added. Water is actually added to that molecule to break it down. And then when a large molecule is built, water is removed. So number one is that water is an essential reactant in our chemical reactions, and then water has a high heat capacity. What that means is that it takes a lot of energy to change the temperature of water. And that helps us to maintain a constant body temperature. Water is an excellent solvent. So a lot of chemical reactions take place in water. The chemicals have to dissolve in water before they will react. We just said this. Water molecules participate in dehydration synthesis reactions and hydrolysis reactions. Water has a high heat capacity. I just talked to you about that. Solutions, typically water is the solvent. Water is the universal solvent. So it's most of the time the solvent in any solution, especially a solution that we would use in lab. But sometimes you would have other solvents. But I'm just saying that water is the solvent many, many times in a lot of solutions. So water would be the solvent, and whatever's dissolved in it is called the solute. So if the solvent is water, the solution is called an aqueous solution. When you dissolve chemicals in water, we say they dissociate or ionize. Substances that release ions when they dissolve are called electrolytes. So sodium chloride would release sodium. Let me see if I can do that. Sodium ions and chloride ions. Sodium ions have a positive charge, chloride ions have a negative charge, and they would form those ions when dissolved in water, so we call them electrolytes, sodium and chloride ions. An organic molecule is soluble, so organic molecules can be soluble as long as it contains polar covalent bonds. So for example, glucose and other sugars are soluble. But lipids are not. Fats are not soluble. Fats and oils are insoluble in water. So a hydrogen atom that loses its only electron, actually the only thing it has now, because it doesn't have a neutron, the only thing it has now is a proton. It is literally just a proton. So it becomes a hydrogen ion with a plus charge, but it is also a proton, because that's where that plus charge comes from, is from the one proton that's in the nucleus of that atom. So a hydrogen atom starts out with just one proton and one electron. When it loses that one electron, all it is a proton. Okay, so I just need you to understand that. The pH scale represents the concentration of hydrogen ions in a solution. So the more hydrogen ions there are, the lower the pH is. The higher the hydrogen ion concentration, the lower the pH. So also, when the pH is below 7, we call that an acid. When the pH is above 7, we call that basic or alkaline. And when it is 7, we call that neutral. Oh, this is important. The difference of one pH unit means a 10-fold change in hydrogen ion concentration. So another way to say that is, if the pH changed in a solution from 2 to 1, if it changed from pH 2 to pH 1, okay, that means that the amount of hydrogen ions went up by 10 times. It's a 10 times increase in hydrogen ion concentration. All right, some pH values here. Blood and most body fluids are 7.35 to 7.45. Define pH. Explain how the pH scale relates to acidity and alkalinity. All right, so an acid is defined as a pH less than 7. An alkaline or basic solution is pH greater than 7. And the lower the pH, the greater the hydrogen ion concentration. So acids have a higher hydrogen ion concentration than bases do. Why is an extreme change in pH of body fluids undesirable? Well, you could go into acidosis. That would be one thing if your pH went too low, or if it went too high, we call that alkalosis, that it can cause you to die. So it's pretty serious. Any substance that breaks apart in solution to release hydrogen ions is an acid. It's a strong acid if the components of that acid completely break apart. So hydrochloric acid, for example, every bit of hydrochloric acid that we dissolve in water is going to dissociate into hydrogen ions and chloride ions when it's in the water. So that makes it a strong acid. And then here's a strong base. Bases release hydroxide ions, OH minus ions. And they can also remove hydrogen ions. So instead of adding hydrogen ions to a solution, they can remove hydrogen ions. That's a base, okay? So here's a strong base, and when sodium hydroxide is completely dissolved in water, then all of it splits up into sodium ions and hydroxide ions. It's probably important that you know OH minus is called hydroxide. Here it is right here. Hydroxide ion, whereas a hydrogen ion is H+. And that's important. All right, weak acids and weak bases do not, so if I put a weak acid in water, some of it would dissociate and some of it wouldn't dissolve in the water. They're important in helping maintain pH balance in the body. A salt is composed of a cation and an anion as long as the cation's not hydrogen and the anion's not hydroxide. So if the cation is sodium and the anion is chloride, that would be a salt. But there are other salts. There's like calcium chloride and magnesium bromide. It would be a cation and an anion together. The sodium chloride is just table salt, but there are other salts. Electrolytes include acids, bases, and salts. These are anything that can conduct an electrical current in solution. In other words, when they're dissolved in water, they actually, can conduct electricity. So sodium, potassium, calcium, chloride, bicarbonate ions. And electrolytes are important. You know that because that's, why we have Gatorade and Powerade, and if you have children, Pedialyte, Buffers are compounds that help to stabilize pH. They resist a change in pH. For example, if the pH becomes too low, they'll remove hydrogen from that solution. Or if the pH is too high, they'll add hydrogen to the solution. Acids, for example, bind to excess hydrogen ions in the stomach and help to raise the pH when it gets too low. So buffers help resist a change in pH. Define the following terms: acid, base, and salt. All right, so an acid is a substance that donates hydrogen ions when dissolved in solution. A base is a substance that removes hydrogen ions when dissolved in solution. And a salt is a cation and an anion as long as the cation is not hydrogen and the anion is not hydroxide. An acid removes hydrogen ions to raise the pH of the stomach. All right, carbohydrates, proteins, lipids, and nucleic acids. That's the last part of our chapter. Carbohydrates have carbon, hydrogen, and oxygen in them. Those are the three elements: carbon, hydrogen, and oxygen. And usually the ratio is 1 to 2 to 1, so especially for smaller sugars. So this is glucose, C6H12O6, and that's 6 to 12 to 6. That ratio, when it's reduced, is 1 to 2 to 1. You could also have like C4H8O4 or C5H10O5, But carbohydrates include sugars and starches. They're a good source of energy, and there's three major types. There are monosaccharides, disaccharides, and polysaccharides. Monosaccharides means literally, mono means one and saccharide means sugar. They're simple sugars, one sugar. And this is what they can look like this in their structural formula, straight chain form, but they're actually shaped in reality. They're shaped like a hexagon. So this one is a sugar called glucose. You can count, there are 6 carbons, and there would be 12 hydrogen atoms and 6 oxygen atoms. So an example of a monosaccharide is glucose.